Hi everybody. Let's talk today about milk analysis and the adulteration of milk. Milk, as we know, is being found to be adulterated today by various common adulterants. This could happen either intentionally or unintentionally. Now, the unintentional adulteration of milk often happens when a cholesterol milk is being formed, because the cholesterol milk often contains proteins and antibodies, and that will affect the taste and the odor of the milk. Now, the intentional addition of sodium carbonate is usually being done to mask the spoilage of the milk by microbes, because when the microbes grow, what happens? The acidity is being found to be changed, and to mask that, some people do add sodium carbonate. Then another common practice of adding water to the milk to increase its volume is always aiming of a profit. But quite often this is easily detectable because the diluted milk is less dense and it can be detected using a lactometer. Now, to increase the density, people also add other adulterants such as sugar, salt and other solids, and there are tests to analyze them too. And we can also see that sometimes, to prevent the microbial growth, various toxic chemicals such as formaldehyde is also being added to the milk. So the so-called good and healthy food that we consider might sometimes be unhealthy to our health, and we need to check the quality of milk quite often. Now, we are going to talk about a few tests which will help us to identify the milk adulteration in an easy manner. Firstly, let me talk about the physical parameters of the milk. Milk, as we all know, is being found to be white in color. So any change in the color of the milk from white indicates that it is being either adulterated, and certain other spoilage causing organisms can happen to be occur into this. Firstly, what you do is you check the container whether it should be clean or not, and you open the lid and check for the odor of the milk, because oftenly off odors are produced by animals' diet, chemical adulteration, natural hormones in the milk, from the milk collection environment, and most commonly even bacterial growth could cause the off odors. Another strategy that we can identify milk using its physical property is to take a small amount of milk and to run it down on a polished surface, and it should leave a streak of milk. And you can also check for the milk sample whether it is free of clumping. So by using these physical parameters, we could judge probably what is the quality of the milk. Now, coming to the chemical properties that we have, milk has a pH of about 6.5 to 6.7, an acidity of about 0.6 to 0.8%, a density of 1.030 to 1.035 kilograms per liter, a freezing point of minus 0.512 to minus 0.550, and any change of these chemical parameters, the violations of the stable normal range of these chemical parameters will give us a direct indication that probably some adulteration or some spoilage is been happening in the milk. If you go to look as such, water is a major component of the milk. Almost 87% of the whole milk is being contributed by water, and the remaining 13% is contributed by total solids, including the fats and non-fat solids such as proteins, sugars as well as vitamins. Even when the total solids are being changed, it gives us an indication that there is something adulterated in the milk. Now, these chemical parameters which we consider here, they give us a first-hand knowledge whether the milk quality is being altered. In addition to this, you can find that the total plate count method and the coliform test can be used to check the microbiological quality of the milk. Now, a total plate count of less than 1 lakh CFU per ml is desirable for raw milk, and a count less than 200 CFU per ml is recommended for pasteurized milk. Whereas in the case of coliforms, a count less than 100 CFU per ml is considered safe for raw milk, and they are expected to be undetectable in the case of pasteurized milk. Now, in the case of total plate count and coliforms, the thing that we have is the results are being obtained only after 24 hours. So the first hand test which we could rely on is based upon the physicochemical properties of the milk. So when you get a batch of milk from a farmer, from a dairy farmer, you need to check for the physicochemical properties on the first hand rather than the microbiological qualities, because the microbiological qualities will take at least 24 hours to give us a result. Now comes to the acidity testing. We have recommended here using the titration method. Here we are checking the amount of lactic acid which has been formed here, or the acids which have been found within the milk. For that, you take 9 ml of the milk in a flask and add 1 ml of phenolphthalein, which is an indicator, and slowly you add sodium hydroxide from a burette to the milk sample and stop the addition of NaOH till it becomes a pink color, and record the amount of NaOH which has been needed to obtain the pink color. Now this is the pink color what is obtained. Now here, how to do the calculation to calculate the acidity? If you had 1.8 ml of NaOH, divided that by 10, so that would give the percentage of acidity, and this 0.18% is a normal acidity percentage for fresh milk without much contamination or microbial growth, and milk that is acidic will require higher volumes of NaOH to become pink, and it will therefore have a higher acidity percentage. Now comes to the next test called the sediment test. This is a test which will reveal the extent to which the visible insoluble matter has been entered into the milk. It's a rapid test indicating on the quantitative measure of carelessness in handling in the milk and the lack of sanitation. But in the milk that appears visible or insoluble, sediment is always associated with a relative amount of microbes. And the test is carried out by allowing a measured quantity of milk to pass through a fixed area of a filter disc and comparing the sediment with the prescribed standards. So let's go into the details of that. Here, now this is a sampler which has been shown here at the corner. You take some milk samples from a well stirred can of milk with the help of a sampling dipper, and here you filter the milk through the properly adjusted firm link discs which has been held in the sediment tester, which I have shown there at the side, and it has been passed through a filtration area of about 28 mm in diameter. After the filtration has been done, you take the cotton disc from the sediment tester and you compare it with a standard disc. Now where is the standard disc? This is the standard disc. Each company has a different standard disc. You will get, according to that, you can have, if you can see the indications, if it is excellent, poor, dirty or fair. Based upon this, you can say the quality of or the level of sediments which have been found in the milk. Hope so this is clear to you. So thank you.